Okay, well, last lesson, I promised you, perhaps promise isn't the right word, but a look at a much harder example using the ideas of discriminant in a question that would be worth quite a few marks in the exam and would tend to be towards the end of the exam as well, probably. So this is a very, very common sort of situation to look at. Now, when you're faced with a question in the exam, you have to look for clues as to what you're being required to do. And there are one or two clues that we can spot in the question to start with. First of all, it talks about finding the range of values of k. Now that suggests we're not going to end up with k equals 1 or k equals 2. We're going to end up with perhaps an inequality, perhaps a region of values of k. So in our mind, let's just remember we might have to use inequalities. Where are the other clues in here? Well, let's look at this phrase here, has no solutions. Now, bells have to ring when you're looking at this, I'm afraid. Where have we come across the number of solutions of an equation? We've come across it to do with our friend the discriminant. Now it says here it wants no solutions, and we remember that that's when the discriminant is negative. How do we use the discriminant? Well, we know the discriminant is b squared minus 4ac. So therefore, I need to know what a, b and c are. You might think, oh, that's pretty easy. But again, because of the mixture of k's and x's here, you have to be very, very careful. So let's just think of our function, ax squared plus bx plus c. So a is the coefficient of x squared. Well, that's easy, isn't it? Because a is clearly 1 here. What about b? b is the coefficient of x, the number in front of x. Well, if we look at it, negative 2k is the thing that's in front of x, so b is negative 2k. What about c? Well, c is the number on the end, but you could also say it's everything else. So, because the number on the end is 1, but we've dealt with the x terms, so this is now everything else. So c is k plus 1. Right, so the discriminant then. b squared, negative 2k squared, minus 4 times a times c. And that has to be negative. Square negative 2k is positive 4k squared. Minus 4 times this bracket. So it's minus 4 times k, which is minus 4k, and minus 4 times 1, which is minus 4. And that has to be negative. So, remember our clue? Inequalities. What have we ended up with? Well, we've ended up with a quadratic inequality. Now, if you were solving that, certainly you would look at that and say, oh, crikey, I can divide by 4 there, so let's divide by 4. So k squared minus k minus 1 is negative. Now, if you think back to the work we've done on quadratic inequalities, you attempt to factorise. Well, after a little bit of thinking, you can see that doesn't factorise. So do you remember what you have to do? It's our old friend complete the square. So it's k, halve the number. Well, there's really a 1 there, isn't there? So it's a half. Square negative a half, which is a quarter, and take it away again. Let's put this on the other side. I'll write it, I think, on this same line. K minus a half squared is less than 1 1/4. 5 over 4. And that's the dangerous one, isn't it? Do you remember, you've got to be really careful here. Do you remember we started doing this by looking at very simple example, something like x squared less than 9, and a lot of people want to put down x is less than 3, but of course it isn't. It's got to be between -3 and 3. So here, carrying this on, when I take the square root, k minus a half will either be less than, now we can't do the square root of 5, we'll have to leave it as a third, but we can do the square root of 4 is 2. And we must put -√5 over 2 on that side. So we're nearly there. I want to know the range of values of k. I don't want this -1/2 in the way, so I'm going to add a half to each of the 3 bits of that inequality. So if I add a half to this, I get 1 minus √5 all over 2, because 1 over 2 is a half. I'm now merging this into a single fraction. That -1/2 disappears, giving me k, and then if I add a half to that, I get 1 plus √5 over 2. So there we have this question, and it's not an easy question. Don't panic if you can't do this sort of thing first time. You just have to work away at it, and don't worry if you get an answer that looks a bit messy. This will often happen in Core 1. They're not obliged to give you numbers that work out easily, I'm afraid, all the time. So watch out for answers that perhaps don't look right, but if you're confident in your ability to keep the calculation correct, then you have to be confident in accepting this tricky looking answer.